Alright, Jumbo. We're going to do a fairly messy one. And you've done the calculations from the previous video. And what you see is one phosphorus. The hydrogens have been mushed together, so that's where you get 4 of them. There are 2 carbons, that's why you have a 2, and you have a 1 there. So 1, 4, 2, 1, 1, 4, 2, 1. As always, the number of atoms the same left and right. Valence electrons, ideal electrons in the Barney world. We add them up and we say, hey, we've got 24 outer electrons to play with, but they have to give the effect of 40 electrons. So subtracting, we get 16, so it means 16 electrons will be involved in 8 bonds. Now we know hydrogen is always on the outside, so we are going to set it up so we go P and C and C and C. Now that's like our backbone, and then we have 1H on the P, and we have 1H on this C, and then this is the same, we have 2 H's on this C, and we are all in business. Now we go crazy. We take care of our hydrogens because we know they can only have a single bond. Chlorine in this case can only have a single bond. And if we look at this carbon, it has 6 electrons around it, so it would like 2 more, so that puts a single bond there. This carbon has 4 electrons around it, it would like 8. So it has no choice but to put 4 electrons there. This phosphorus needs another lone pair there, and this chlorine needs to get to its octet. So we do this, and we say, okay, let's do some overlapping so you can see the bonds. And every element now has 2 if it's hydrogen, or 8 around if it's any other element here. We go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Has 24 dots. We know it has 8 overlapping places, 8 bonds. 1, 2, 3, 4, 5, 6, 7, 8. So that is perfect. Remember, when you have 4 electrons for a bond, that is going to be a double bond. That would be more like a chemistry 11 question where we're putting a lot of elements and their atoms together, but for an example, it covers a lot of the terrain.